Hello and welcome. I'm Barbara Barrett, a member of the board of directors of the Atlantic Council, and I was the 25th Secretary of the United States Air Force. Welcome to the latest event in the Captains of Industry series. Today's topic, Digital Design in Defense, features Wes Kremer, the president of Raytheon Missiles and Defense. Today's event is brought to you by the Council's Scowcroft Center for Strategy and Security. The Scowcroft Center honors the late General Brent Scowcroft's legacy of service. Also, it embodies his ethos with the center's nonpartisan commitment to the cause of security. It supports U.S. leadership in cooperation with allies and partners, and it mentors next-generation leaders. The Scowcroft Center creates forward-looking assessments of the trends, technologies, and concepts defining the future of warfare. Today's event with Wes Kremer characterizes that mission. One of the most important technological trends in the modern aerospace and defense sector is the software revolution. In 2011, Silicon Valley icon Mark Andreessen famously declared that software is eating the world. He supported his ominous observation, saying that a dramatic and broad technological and economic shift is occurring in which software companies are poised to take over large swaths of our economy. Well, a decade later, defense is not immune. Software drives innovation and productivity throughout defense systems. Defense industries depend mightily upon digital engineering, and more so each day. Software not only controls systems performance, but software also transforms design, development, and production. As Secretary of the Air Force, my duty was civilian oversight of the ongoing digital transformation of the Air Force and the Space Force. However, long before my time at the Pentagon, from the boards of several technology companies, including Raytheon, I participated in building essential digital engineering strategies to iterate technology faster, to meet the needs of warfighters today, and to anticipate the threats of tomorrow. Is software eating the defense world too? What are the practical implications for defense contractors? How are acquisitions practices changing? And what more can we do to deliver innovative capabilities faster to outpace tomorrow's threats? To address cutting-edge defense innovation, the Atlantic Council welcomes Mr. Wes Kremer to our Captain of Industry series. Wes is president of Raytheon Missiles and Defense, a business of Raytheon Technologies. He leads 31,000 employees and is responsible for a broad portfolio of air and missile defense systems, precision weapons, radars, command and control systems, and advanced defense technologies. An electrical engineer by training, Wes Kremer has decades of executive experience in aerospace and defense and has held multiple leadership positions at Raytheon prior to its 2020 merger with United Technologies, including president of both Raytheon Missile Systems and Integrated Defense Systems. Also, I can't help noting that he is a U.S. Air Force veteran. Wes was a weapons systems officer on F-111s and F-15Es. He flew more than 90 combat sorties in Iraq and Bosnia. Wes, thank you for that, and thank you for joining us today. Moderating this conversation is Mr. Steve Grunman, Senior Fellow at the Atlantic Council's Scowcroft Center for Strategy and Security. Through programming like this Captains of Industry series and the associated Defense Industrial Policy series, Steve engages business and government leaders to lend their perspectives about issues that haunt defense ministries and defense industries. Finally, I thank both speakers and especially our virtual audience for participating in this important conversation on digital design in defense. And now I invite Wes and Steve to begin their discussion. Steve?
That's terrific. Thank you very much, Secretary Barrett, and welcome to the Atlantic Council. Secretary Barrett recently joined our board of directors. Those of us in the Scowcroft Center are especially pleased and proud that she's done so, not least so that we can prevail upon her for things like she has just done, made a great introduction to this next event in my Captains of Industry series. So we welcome here Wes Kremer, the president of Raytheon Missiles and Defense. And we're going to have a conversation about digital design and defense. It'll get everywhere from, as Secretary Barrett said, whether software is eating the defense world too, to a more general conversation about digital tools, digitalization, its impact on the defense industry, its competitive landscape, and not least the customer. Let me make the further point before we get started that the mission of the Captains of Industry series is to give senior executives in the aerospace and defense sector a prominent platform from which to talk about the public interests their companies serve and the public policies that shape their markets. This topic, this speaker, this captain are all perfectly fit to that mission. So let's dive into it. Welcome, Wes. Welcome to the Atlantic Council's Captains of Industry series.
Hey, Steve, thanks so much. Happy to be here today.
Terrific. We have until the bottom of the next hour, so about 55 minutes, plenty of time, I think, to plow the ground that has been suggested here. However, I want to start with a couple of predicate questions just to give the audience the right context for our conversation about digital tools and the other things that I previewed. And the first piece of that context is about you. This is the traditional first question I ask all of the captains, which is to give the audience your origin story, if I can call it that, your origin story, at least in national defense. And if that goes back to kindergarten, I want you to start there. But give us your origin story in national defense, and then an indication of how that origin figures into your stewardship of Raytheon Missiles and Defense.
No, thanks for the opportunity. And like I said, it's great to be here today. So, I grew up in a really small town in Montana, and, about high school time, had these dreams of, flying in the Air Force. And, I was fortunate enough to be able to get an ROTC scholarship. I went to Montana State University and, went into the Air Force and for 10 years, got to fulfill my childhood dream of flying fighters. And as Secretary Barrett mentioned, I was weapons systems officer in both the F-111 and then the F-15E. Following that, I got out and, really had the opportunity and wanted to stay in the defense industry and joined Raytheon. So I've been with Raytheon about 19 years now and had the opportunity to be in many leadership positions. And so to me, this is an important part. And I think when you look at many of the employees in the defense industry, we have a lot of veterans and we have a lot of people, a lot of our employees and engineers, are able to connect with that mission of defending our nation and our allies' interests around the world. And so that's what, motivates me to come to work every day.
All right. Well, we'll have to talk about the fishing in Missoula on some other occasion, but I promise you I'd like to do that.
Okay.
Okay. So a second predicate question, which I welcome you to take some time to develop, not least because of the merger of Raytheon with United Technologies that I think concluded about a year ago. The portfolio that now comprises your business, the bigger piece of which people are most familiar with, was called Raytheon Missile Systems. And so now I'd invite you to give us an orientation to the full portfolio of businesses that are in Raytheon Missiles and Defense now.
Yeah, Steve, thanks for that opportunity. As you mentioned, the timing of the merger between Raytheon and United Technologies, I guess depends how you look at it, was timely on one thing or was really untimely on another. But, really, we announced the merger back in the summer of 19. And then the closing date was on April 3rd of 2020. And so, literally about 3 weeks before that was when the United States pretty much shut down and the world shut down. And so we all started working from home and, we transitioned over a very short period of time to a virtual environment. So we really didn't have the opportunity to really tell the story of what we did leading up to the merger and as part of the merger. And so, to recap, Raytheon originally had 4 business units, and we had intelligence and information services, and we had space and airborne systems. And those 2 businesses combined into what's now Raytheon Intelligence and Space. And then we had, integrated defense systems, which portfolio includes all the big radars, the early warning radars, things like the Spy-6 for the Navy, and then of course the Patriot weapon system was the big thing. So when I was the president of Integrated Defense Systems, that was the portfolio. The large part of the international portfolio for legacy Raytheon was in Integrated Defense Systems. And then, where kind of my roots was with Raytheon Missile Systems. Actually came up through the ranks in kind of the missile defense arena. Was a program director for Standard Missile 3, and then that portfolio of MDA programs. And when I came back as the president, got to see the entire portfolio, which includes our air-to-air weapons, AMRAAM, AIM-9X, precision guided weapons, HARM, Griffin, Paveway, and then the naval missiles, SM-3, SM-6, RAM, ESSM, Phalanx, so kind of that whole naval ship defense. So when we decided to come together as Raytheon Technologies, we took those 4 Raytheon businesses and merged them down to 2. And so the formation of Raytheon Missiles and Defense really allowed us to be a much larger organization than we are today. But to me, more importantly for our customers, is it now put together that end-to-end ability from sensor to effector. And that's really the whole thing, whether we talk about it in terms of a kill chain or a mission thread, to go all the way from that sensing through the command and control structure to then the effector of being able to put energy on target. And that's the real value that we have in Raytheon Missiles and Defense. And I will say that, the feedback from our customers has been very positive in this arena. It's allowed us to take more of that focus and move from a products provider to more of a system solution provider. So I'm really proud of how far we've come with Raytheon Missiles and Defense, and really done that in a virtual environment. And now being a part of Raytheon Technologies, gives us a significant presence as a $65 billion a year company, and all the things that go along with that of our ability to invest to continue to take technology to the next level. And there's some certain benefits of having that size, and we're seeing the results of that. We're also seeing a lot of synergies. At its heart, both United Technologies and Raytheon were very much technology companies. And so, we have that intellectual curiosity, we have those great engineering teams. And when we look at synergies and things like material sciences, so many different connected environments, those are all things where we're already seeing those synergies in effect in the merger as part of Raytheon Technologies. So hopefully that gives a little bit of background, kind of what happened during the merger. It's kind of interesting that, the RTX leadership team, the first time we came together face to face was June of this year. So literally 15 months post merger was the first time we actually all met face to face. So really, kind of leads into our topic here of not just digital technologies, but just technology in general, of how far we've come to think that you could actually go through and complete a merger of that size, the largest in the history of aerospace and defense, and do that completely in a virtual environment and pull it off successfully. And we are, as our third quarter results, delivering for our shareholders.
Yeah. Let me ask just a couple of clarifying questions in this regard. One of which is, give us a sense of your geographic footprint, just of RMS. Where are the major elements of your geographies?
Yeah, so the major centers of gravity for Raytheon Missiles and Defense are Boston and Tucson, Arizona. Obviously, we have folks around the world. The largest part of our international military business is within my business. So I've got people all around the world. We also have pretty significant integration facilities in Huntsville, Alabama, and Camden, Arkansas. So some other Louisville, Kentucky, where we do integration.
And extrapolating maybe off of yesterday's earnings announcement, what is the sales and employment base of RMS? Or RMD, excuse me.
Yeah, we're a $16 billion organization within the overall RTX, and as Barbara had mentioned, about 31,000 employees. So it kind of gives you an idea of the scale.
Right, she did. That's right. Okay, good. I think it's important for an audience that probably doesn't spend as much time as you and I do staring at the aerospace and defense industry every day to have that context, both about you and about your business. A big business in defense unto itself by any measure, $16 billion. Okay. let's open up chapter 2. Let's talk about digital design in defense. I won't belabor the question any more than to say, how is the digital revolution, in however dimensions you want to describe it, affecting RMD?
Yeah, Steve, there's so many ways we could go here, and obviously we got some time, so I think we'll explore some of these options. But just when I look at it, I mean, certainly going down digital design is not something new. It's been going on for a long time. You look at, models, 6DOF models that do flyouts for missiles or radar predictions. I mean, these have been going on for decades, and obviously the fidelity of those things has gotten better over time. On the software side, we've been talking for a long time. It started out with Agile or Scrum, and we've evolved to, DevSecOps kinds of things where, we literally, develop a mission thread, compile the code every day, those kinds of things like that. I think what's really gained momentum in the last couple of years, and it is, is accelerating at an exponential pace, is pulling all of those things together. So it's not just the performance models, it's not just software. We're actually doing a digital revolution now in hardware design, right? And that is what now is tying this together. We're looking at things, the cost model. How do you tie all those things in? And it really is about going faster. And I like to tell my team that, it isn't just about speed on the battlefield. It really is about speed to the battlefield. And you can't just accelerate software or just accelerate performance. We have to be able to accelerate the entire engineering design cycle. And more importantly, and here's where I think there's some real opportunity, is on the test side. How do we accelerate the test cycles such that we can actually field the capability quicker? And so when you start to put all of those pieces together, and as computing power has increased and the fidelity of all of these models has improved, what we're seeing now is that interconnection of those models and that ability to draw that digital thread all the way through the design cycle. And I think that's what's different right now.
I wonder if I could just ask you to take a program at maybe a relatively early stage of development, just to illustrate what you're talking about for the audience, how you've employed those tools in development.
Yeah, I think a great recent example is our hypersonic air breathing weapon concept, or the HAWK program. A DARPA program to really push technologies around an air breathing hypersonic weapon with a scramjet. And what we did is, we worked for a couple of years and recognized that, hey, the challenge in hypersonics is you really have to balance how do you manage the thermal loads, and you have to balance that with your performance model and your mechanical model. And so that interconnection of those three models, it used to be done very much a sneaker net kind of thing, of take the results of one model, feed it into the other model. Of course, you have different parameters. It's not a pure matchup of being able to carry over the inputs and, go through iterative cycles on that. And what we were able to do is to connect those models together and very quickly come up with a digital design that we sent out, and literally was 3D printed, and we put that into a wind tunnel. And we, 2 years ago, ran a prototype of this HAWK design through a Mach 5 wind tunnel. And what was amazing on that is how accurate our performance models were. In fact, we were in a NASA wind tunnel, and the first few runs, we had some very strange results. And, the engineers huddled for a little bit, and they said, I think there's a problem with the wind tunnel. And, you kind of go, yeah, right. But, it was true. And we got with NASA, and there was actually a disturbance in the airflow, was corrected. And then from that point on, we had actual wind tunnel data that was almost perfectly modeled what we had predicted. And we went from that.
I can just interrupt you. So the engineers had such confidence in what the model had predicted that they were willing to challenge the instrumentation of the tunnel.
Yes. And I mean, but that, I think that, started to show the power of this. And we literally then went from a wind tunnel to a free flight test here in less than 2 years. And the same thing, this first flight test that we had 5-6 weeks ago, we saw the performance data almost perfectly overlay the model data. And I think the power of that is Now, how do you accelerate the flight testing? Many weapons programs go through literally years of flight testing. And if you have an accurate enough performance model, what's the real required number of flights that you can do to anchor those models and to be able to, provide that confidence to then go forward into production or fielding much quicker? And when you start to think about that, it really starts to, your mind can start to go to, hey, these are the kinds of things where we can actually go faster. And, this has been the mantra in the Pentagon for the last, 4 or 5 years now, is going faster. We have to be able to outpace the threat. And to do that, we have to change the way that we design, test, and field weapon systems. Not only do we have to be faster, but we have to be more efficient. We have to drive cost out of it. And, this digital technology is really getting to that.
Let me jump forward to something I was gonna get to a little bit later, but it dovetails well with this point. So, are the customers, are the program managers ready to go faster? Do they have the kind of confidence in these models that your engineers do, or does something about either acquisition practices or regulation need to be updated for 21st century software?
Yeah, that's actually a great question. And I would say it's mixed on that, right? There are a lot of people in the Pentagon, a lot of senior leaders that really are fully behind digital design and really pushing to go faster. But there's inertia against that in the system itself. There's a large bureaucracy. There's a long time of the way we write contracts. And so, what's strange is that actually, in my mind, one of the biggest challenges here as the defense industry combined with our government customers is to have a different contracting strategy. We can use the example because we've been going through this for many years back on the software side of agile software, DevSecOps, right? If you're going to do that, you can't then write in a contract that you're going to do a software or a waterfall software design process, right? At the end of the day, we have to honor the contract. So getting the contract terms to match the technology is one of the challenges. There's also big challenges around intellectual property and things like that. Might be something we can touch on too. So, but I will say and give the leadership in the Pentagon credit. I think we're moving faster towards digital design than I would have predicted even a few years ago. We've overcome a lot of the inertia, and let's face it, on the big defense primes, we have a lot of bureaucracy and inertia in our systems too. Yep. And so it's a shared journey here of how do we get to not only embracing this, how do we prove that technology, how do we write contracts in a way that takes advantage of that, and then how do we understand what the limitations are, because there's still a lot of opportunity and we're far from perfect in this, and digital design doesn't solve all of the challenges of fielding these incredibly complex systems that we do in the defense industry.
Okay. Let me pivot from design to the products themselves. Is digitalization, modern software, changing the products? We've been coding into our weapon systems for 60 years, but is it different, or is it just a further, is it a straight line extrapolation from the coding we did in 1965?
Well, certainly the computer programming languages that we have today are much faster. They're much easier to write in. I think about it, my son recently graduated from college and he's an engineer. And I think that back when I was in college was right as we were transitioning from the punch cards to the first, PCs. And you used to take a class, a Fortran class, and the class was about how to learn the language. What happens in college today is that when students sign up for a class, is they get the book on the language, whether it's Python or whatever it is, and they're expected to know the basic language, and the class is about how to actually apply that. It's not to learn the language, right? And that's because the higher level languages are easier to be able to program. It's a little bit more, apparent on what things are, and you got to learn the concept. So I think that we've seen software move along at an incredibly rapid rate. We joke, and I'll say my software engineers joke that they fix the problems. We get to a point in hardware and we say, we're going to freeze the design on hardware. And, if we find additional problems in test, we're probably going to fix it in software or firmware. And most of the capability enhancements that we do are going to be in software, right? So software plays, I would say, an outsized role that continues to grow in the capabilities of our weapon systems.
Yeah, I would expect so. But without making this a test question, but are systems different? I mean, can we make different weapons now, or at least substantially different performance characteristics of weapons because of the digital software capabilities? You've as much as said we have, but I guess I want to pound the table. Yeah. I'm fine if I'm hearing that right.
No, Steve, I mean, that's great. And I think, to add some clarification, I'll use a couple of examples.
Thank you.
So, something like the Standard Missile 6. I mean, the Standard Missile 6 has multiple mission capabilities. It's both a surface to air weapon to go against aircraft. It also has a surface to surface capability to go against ships. And then it has what we call a sea-based terminal, so an ability to go against a counter ballistic missile. Mm-hmm. And essentially what it does is it has, different software loads that it can dynamically do. So you get a multi-mission capability out of the same piece of hardware, largely enabled through software. You talk about in radios for, almost 2 decades now, we've talked about a software-defined radio. Now we're talking about software-defined radars. So where a radar is not just a radar, it's also can be a comm link. It can potentially even be a directed energy kind of source. So with software, we define what that aperture does. And when you think about on a radar to go between a radar and a comm link, it's 2 very, very different kinds of things. I mean, one, getting a little technical here, you're operating in compression, and one, you're out of compression, operating in a more linear mode. And so when you think about what that software does, it makes that aperture look completely different.
Mm-hmm. Mm-hmm. Yeah. Okay. That is what I was trying to tease all the way out. Exactly. Wes and I will have about another half hour to go here. And so let me, before I ask my next question of him, remind the audience, encourage the audience to ask questions and remind them or make known to them how to do that. At the bottom of your Zoom screen, there is a tab that is labeled Q&A. And if you type your question in there, my friend, I prevailed upon a great friend of the council, Byron Callan, managing director at Capital Alpha Partners, to curate these questions. And then in 10 minutes or so, I'll ask Byron to offer up the better of the questions for us. So I know Wes very much would like to take questions from the audience. Let me, with about 10 minutes to go before I turn to Byron, let me just remind the audience, please, to do that and how to do that, which is using that Q&A tab at the bottom of your Zoom screens. Let me keep going here. One more dimension of its impact, digitalization, the software revolution on defense, and that is on people. You've alluded to your software engineers. I guess I'm interested in a couple aspects of that, and that is the employment base of our RMD altogether different than what you remember it in 2001 or whenever you joined the company? And how hard or easy, or at least different, is it to attract, retain, motivate that kind of a workforce than an industry which we might associate traditionally with a little bit more metal bending and soldering?
Yeah, we've definitely seen the shift to, more software, and it's, frankly, it's not just computer science and software engineers. A lot of our electrical engineers go down and write firmware and, much lower level kinds of things, algorithms, things like that. So, we definitely, I think over the last, 10 years have seen a shift, and cyber, right? That's the other thing that really drives more of kind of the software kind of thing. So we definitely see a shift in that a larger percentage of our engineers are working software or firmware kinds of things. I think switching to the talent side of, how do we continue to not only recruit, but to retain? And I think, all of industries face the same things that, our younger employees are more flexible, they're more mobile, companies don't have pension plans and things like that keep those long-term hooks in things. And so we see more movement in that. So, we have to do different things to, both attract and retain. And also, I think that what all of us are seeing in industry is that the competition for talent is not just among our industry. It's not just among our peers or competitors. A great example is something that we do is discrimination, right? So whether it's with radar or infrared, you see a target and you have to try to figure out what that target is, or is that the right target? And that's all done with software algorithms. And that used to be something very unique to the defense industry. Well, now those same engineers are getting recruited by Amazon and Google, because at Amazon, to look at a buying pattern is essentially a way of the same kind of algorithms that you do for discrimination and missile defense. And so what we're seeing is that, our competition for talent isn't just peers in the industry. It's the Amazons, the Googles, the Microsofts, the Oracles, things like that is where we're seeing that. And that, raises the whole level of not only compensation, but making sure that we're doing exciting work. I think the one advantage that we have in the aerospace and defense industry is that connection to the mission, right? And when we look at interviewing and hiring people, we find that many of our employees have that connection to the military. They have an uncle that was in the military, they have a son, they have a daughter, they have somebody, a father kind of thing. And that connection to the mission of what we do, of whether it's providing, safety in airplanes and jet engines, or whether it's, missile defense and protecting our country and our allies, that connection is what really we try to drive for our employees.
Yeah, I did a Captains of Industry event a few years ago on venture investment in corporate venture investment in aerospace and defense. And the point was made by one of those panelists that one of the great advantages, it's tough recruiting in this field, but one of the advantages that the aerospace and defense industry has is they have really hard problems, and really good engineers like really hard problems. It's one thing to make an app for my iPhone. It's another thing to differentiate various things flying through the air.
Yeah, and I think, people also like to do classified work. Let's face it, they get to do some things that are truly on the leading edge of technology, and that appeals to engineers. I mean, engineers, have a natural curiosity, and they like to be on that leading edge of whatever it is. And certainly in the defense industry, there are those kinds of opportunities.
Let me stick on people for a minute and pick up your point about how the first 15 months of the new RMD was, for all intents and purposes, virtual. Now that hopefully we are getting back to normal, undoubtedly there are practices that were adopted during the pandemic of necessity that either facilitate recruitment and retention, or maybe just plain effectiveness. Can you give me some thoughts on that? Is that right, or are we going back to before in terms of workforce management?
No, I don't think we ever go back to before. And I like to not say, go back to normal, go to a new normal. And I think that new normal, there's some really, there's been certainly some challenges come out of what we've learned over the last, 20 months, but there's some real opportunities here too. And a couple of them that I look at is just being more flexible in our work environment. I think that, what all companies are struggling with now is not the full-time on-site worker or the full-time remote worker, struggling with that hybrid, that in between. What does that look like? Is it coming in 2 days a week? Is it 3 days a week? Is it 1 day this week and 5 days next week? What does that look like? And what's the driver on that? Do you want a regular cadence? I mean, certain functions, maybe something like communications or legal or something, it might be good if they just came in on Tuesday and Thursday or something. But on a lot of them, we're organized around our programs, and programs go through different phases. And, as you're getting ready for a technical interchange meeting or a preliminary design review or critical design review, you're probably going to need more of the team in there every day working together. Whereas, maybe after that, people can go back to doing some more remote work as they work some of their individual, things on a program. And so then trying to figure out, so what does that look like from a footprint perspective? How many desks do I need? Because if a team is coming in, I can't have a team of 15 people come in and then have them dispersed across 5 different buildings. I mean, then they may as well stay home because what they're coming in, it's to collaborate in that environment. So now reservation systems of how I allocate conference rooms, how I allocate desks, those kinds of things. And I think that's what all companies are going through and struggling with right now, is figuring out what does that hybrid workforce look like. But I think the other thing we're seeing in being flexible is that we're able to attract and retain a larger core of workers, right? There are, let's face it, people that have, certain family situations. I mean, maybe coming into work every day or being in at 8 o'clock in the morning, doesn't actually jive with getting kids to school, or staying till 5 doesn't jive with getting kids to soccer practice. And so I think what we're learning out of this is that we're seeing that our employees working remotely have been incredibly productive, and that we need to be, as leaders, more flexible and offer more flexible work arrangements. And after all, it should be measuring about, what do we get accomplished at the end of the day or the end of the week, not which hours are we sitting behind a desk in the office.
Yeah, no, that can be very attractive to folks. So I do see a queue of questions building up. And so I'm going to ask one more question, and then I'm going to turn to Byron to offer up some of the questions that the audience has. And this has to do with the competitive landscape. So hearkening back to that quote that Secretary Barrett mentioned from the famous Mark Andreessen, that software is eating the world. The further meaning of that, as I understand it, was that he thought, software companies would leap over the next generation, maybe quicker, in his view, to the top of the value chain or the success chain in all industries. Well, it can't be said that there is a per se software company that is any one of what we today would call a leading defense contractor. And yet, I wonder if I could, draw you out. How has the competitive landscape changed because of the software revolution and the digital revolution?
Yeah, and maybe what I'll do, Steve, is maybe throw a little bit of cold water on that assumption from years ago, is that at the end of the day, software still runs on hardware, right? And you have to, if you're going to field a capability or a system, you have to have both the hardware platform and then the software to operate on that. And although we've seen incredible accelerations in overall things like performance models, 6 DOFs, the things that we're doing in additive manufacturing, 3D printing, where we're still lagging as an industry and as a country is, I'll take something as simple as an ASIC, right? An application-specific integrated circuit done on silicon.
I would have asked you to spell that out. Go ahead.
And ASICs, right? They're in every single one of your kitchen appliances. They're in every circuit board in your car. And certainly they're in the circuit cards that are in radars, missiles, and things like that. If you have a complicated ASIC, and by complicated, I mean one that we would call a mixed signal ASIC that has both digital and analog parts of that circuit, the odds of doing a first pass success in a digital design is pretty much 0. It doesn't happen, right? And so what happens then is you have to do that design and you send it out to a fab, and they make wafers and you cut them up and then you put it on a circuit card, and then, or you put it in and you test it, right?
See what happens.
And you go through a couple of iterations of that, and now you've got an ASIC that works, and then you put it on a circuit card assembly. And again, we have almost no ability to predict something as simple as the BizWar end-to-end in a circuit card. And so we make a circuit card, we populate it, we put it on a test stand, we measure things like the BizWar, things like that. We go and we tweak a few resistors or capacitors on that. So in other words, what I'm trying to say is, down at the core level of the hardware, the fidelity of those models is not to the point of where we can have first pass successes. So we have to iterate and we have to actually build hardware. The dream of digital design is that you could do everything, the circuitry, the mechanical, the software, all of that in a digital environment. And you would essentially get to a critical design review and review the models and hit print. And when you hit print, it would go out to all your suppliers and all those things would get made and you would assemble it. And the first time it would work. We're not there yet. And that's why now we're getting better every day on that. But when you think about the end state of what true digital design is, vice where we are today, we're further along in software and we're coming along real well, I would say, on the mechanical, but on the electrical side of things, which is core to hosting software, we still have a lot of work to do in that area. And that's becoming the long pole in the tent that's still driving the engineering development timeline. And until we can address some of those long poles, this whole speed to the battlefield and cutting the design time of systems is still a work in progress.
A great software company can't work the middle portion or not as effectively as those of us in the industry who've been doing it for a generation. That integration, the application and integration of these systems. Is that how I'm hearing you?
Yeah. That in order to do a completely digital design, you have to be able to do not only the software, you got to be able to do the hardware platform that you're going to operate on. And then you have to be able to integrate all of that and predict the performance model, the performance of that system in its intended environment. And although we're making progress in all of those areas, I would assert that hardware piece, especially the electrical hardware, circuit cards, ASICs, things like that, that's the part that's still the long pole in the design timeline.
Okay. I see my friend Byron Callan. Welcome, Byron. I also see you've got a good queue of questions, or at least a number of them. I don't know how good they are. You be the judge of that.
Okay.
Give us some questions from the audience, or give Wes some questions from the audience, more to the point.
Thanks, and good morning, good afternoon, Steve and Wes. The first question, Wes, I just want to touch a bit on suppliers. We had a question for Roel Vandeveld. I'm going to read the question. He said, multidisciplinary design optimization software stimulates collaboration, essentially breaking down silos and enable a cultural change, not only between departments, but also between primes and suppliers. So what's your strategy? How are you handling this? How are you working with your suppliers to bring them up to the standards that you expect and are now operating with?
Yeah, no, Byron, that's a great question. And I'd like to, spend a little bit of time on this one because it really touches on some topics that we didn't really cover in the dialogue to this point. So one is that truly that is the vision. When I talked about, hey, you design this whole thing and you hit print, that it goes out to all of your supply base. Well, in order for that to happen, everything that your suppliers are doing, whether it's circuit cards or it's, mechanical parts or, whatever that is, brackets, cables, harnesses, all of that has to be integrated in the overall digital model of your system. And as suppliers make changes, that has to then migrate all the way through to your top level analysis, your systems analysis, right? So it's an incredibly connected ecosystem to be able to do that. And that's certainly the vision. And in order to get to the end state, we have to be able to do that. There's two big challenges with that we're still working. One is the obvious one, which is cyber, right? You're in a cyber environment, you're only as good as your weakest part. And so when you start going down multiple layers in the supply chain, we have challenges today about cybersecurity on that. I mean, we want to bring on, diverse and small business suppliers, but you get down to a fourth or fifth tier supplier that's machining parts and, their IT might be their 12-year-old nephew, might be their IT support for their router, right? And so we have, and if that supplier at a fifth tier has access to the entire model or input to the entire model, that creates a potential weakness. And so, there's been a lot of work done around the risk management framework that the Department of Defense has rolled out and how that applies throughout the entire, defense industrial base. And so that's one area that, we're continuing to work. The second one that we didn't touch on is how do you protect intellectual property? And so at multiple levels is, our suppliers, they invest as primes, we invest, and we want to protect our intellectual property with the US government. But the US government, at the end of the day, wants to own those models so that they can compete production. And that's something that I would say is still very early in being worked out, is how do you protect intellectual property at the supplier or sub-tier level? And how do you protect intellectual property either between primes or between the primes and the government? And so that's another area that we didn't really touch on today. But to me, that's as big of a challenge as the contracting side of getting the contracts right, is we have to figure out how we're going to solve the intellectual property issues.
Yeah, particularly if I may butt in, Byron, as indications continue to grow that at least some of the acquisition strategies are deliberately separating development from production.
Yeah.
Right. When that begins to happen, then getting compensated at the very least for your IP adequately is critical, but it also sort of changes the whole business model of defense if they were to do that. Give me a reaction to that. Is this a trend, the separation of development from production, or is it just a couple of one-off instances?
Yeah, well, absolutely. It's not only a separation, but there's also a desire of how do you build just a few of something, then iterate the design, and then just build a few more, and you're always competing that. That becomes a hard model for industry to invest in, right? We invest in knowing that we're going to have production for some amount of time. And, that's how we do the calculus of the investment on that. And so again, these are all solvable problems, but right now things are moving pretty fast in a lot of different areas. And this is something that, is not unique to Raytheon. This is, an industry-wide thing, something that, I think all of the defense primes are working through AIA right now on, what is that framework going to look like? You can also get into who's going to actually own the digital infrastructure. Is that infrastructure going to be, at the government level? I mean, there's some advantages to that of, right now to get certification or authority to operate on a classified platform is a very long and drawn out process that you have to go through as industry. There's some advantages to maybe being able to operate on a government platform, but then again, how do you protect your intellectual property on that? Different companies are going to want to use different tools. They're going to want to structure data differently. So do we get to industry standards on how we structure data and what tools we use? Lots of unanswered questions in that arena. But I view that still as progress, because it means that we all believe that there's a way that we can use digital engineering and digital technologies, and we can go faster, we can be better and more cost effective, and we just have to work through some of these challenges.
Yeah. If there were more than 10 minutes left in our conversation, I would invoke JADC2, Joint All Domain Command and Control, which you are at least implicitly alluding to, and ask you to talk about that. But maybe Byron has a question along those lines. So let me turn back to Byron again.
Well, it's a little different, Wes, but it comes from Michael Lima, who's actually an industry fellow with Raytheon Missile and Defense. And I'm just curious, he's curious, kind of how does this change best practices? How do you promulgate best practices through the organization? I'd say not just for your division, but for the rest of the company, because that's really one of the visions behind Raytheon Technologies, is sharing this technology across the different groups and sectors.
Yeah. Well, I think, I touched on this a little bit earlier in the conversation with Steve there about that, driving efficiency isn't just on the government side. It's also on the industry side. I mean, we are, very large organizations. We have bureaucratic processes that slow us down. And if we're going to go to a digital environment, we have to significantly change and streamline our business processes too, right? Our business processes are designed around the way the government contracts with us, which is very much we do a system requirements review, we go to a preliminary design review, we go to a critical design review. The artifacts of that are thousands of pages of PowerPoint slides. Where in a digital environment, the artifacts of each of those is just an update to the model, and a model that's signed off and agreed to, a joint model between the government and industry. Even the cost model. I mean, think about how much time we spend in negotiations around the cost. And if we had an agreed upon cost model, that would be something much easier to do and would streamline a big part of the acquisition process. So those are all things we have to adjust our business processes. And, I'll share a little bit of dirty laundry on legacy Raytheon is that, for a long time, we were one of the last companies that was still using Lotus Notes as our email, and we switched over to Outlook. And I remember that when we were doing that and the initial requirements came together, we had from a bottoms up kind of thing that the only way we could switch to Microsoft Outlook, the most widely used email program in the world, was that we were going to have 72 customized features, and that would be the only way we could do that. That we were unlike any other company in the world. We had to have that. And just to show that's the kind of culture that we're trying to overcome, not only on the industry side, but there's similar things that go on in the Pentagon, right? Of where there's that we've always done it this way. And now if we're going to go to this new way of doing it, we can't take this new way and try to impose our old processes. If we're going to do it a new way, we have to embrace the tools, and then we have to adjust our business processes to work within that. And that, to me, is the cultural side of change here. And, we didn't talk a lot about that today, but you can arguably say that's harder than the technology side, is the culture side.
What else you got, Byron? We've got time for maybe one or at least one, probably two more questions.
Well, I guess it's a little off topic, but kind of related to workforce issues. It's a question that's posed by Marcus Weisberger, and it's just kind of the whole question about the vaccine mandate and your employee base. Kind of where do you stand on this? I know it's come up on some of the conference calls. Greg talked a little about it. Your CEO talked a little bit about it in the conference call, but how about your group? How's this looking given the December 8th deadline?
Yeah, we are smartly marching towards that December 8th deadline. Within my organization now, we're in the mid 90% vaccinated. But when we get down to that final 2 or 3%, and I don't know exactly what that number is going to be, it's going to be some hard discussions with employees. And, unfortunately, there's not really much wiggle room on the executive order as a covered defense contractor. We have to comply with that. We certainly, from multiple perspectives, have been very encouraging of all of our employees to get vaccinated. And we'll have to do our best to make sure that we don't break something there, but we're pressing forward to be compliant with the December 8th deadline.
Yeah.
One more, Byron, and then I'm going to steal back the last few minutes for a final question of my own for Wes.
Well, I'm curious, Wes, this comes from Michael Heschel. I apologize if I mispronounced the name, but you referenced target discrimination is similar to the needs of Amazon and Google from a software perspective. But he's kind of curious, what functions from a software or digital design standpoint are still unique to defense?
Well, I'll take a simple one in like the missile business, guidance, navigation, and control, right? I mean, not a lot of applications outside of defense to be able to have something that's flying along at Mach 3 or 4 and doing a closed loop kind of guidance to a target, right? So, there are certainly things like that we do that are pretty unique to the defense industry.
Right. Not yet, anyway. Although I do think there are some concepts for maybe not fully hypersonic, but supersonic air transport that may start to compete with those engineers at some point.
Yeah, although I think the supersonic air transport will probably be trying to avoid other objects as opposed to merging with other objects.
We hope. We certainly hope. Okay, that's great. Let me take back the con here for a final question. I want to scope all the way out to kind of a decade. And your answer to this question may exceed the strict scope of our conversation around digital tools. Looking ahead a decade, what is your sense of a couple of big strategic challenges for RMD? What are the things which are going to be hard, got to get right to stay at or at least near the top of the stack of your competitors by the end of this decade?
Yeah, well, I think, as with any large company in an industry, is you always have to think, what are those disruptive technologies? And so, we talked about hypersonics, and hypersonics are certainly in those early stages. And there's two aspects of that. There's that hypersonic weapons will probably displace some of the current weapons that we sell today. And then there's the whole idea of counter hypersonics. So you can kind of think of that of the analogy of ballistic missile defense, but now counter hypersonics has a whole different set of challenges of things that are not only moving fast, but they're very maneuverable, and they don't follow a predictable path. And so there's incredibly challenges there, not just to Raytheon, but to the entire industry. And so, I look at how do we maintain our position that we have in ballistic missile defense, and how do we apply that to counter hypersonic?
Yep.
The other disruptive technology is speed of light weapons, right? Whether that's lasers or high powered microwaves, or cyber types of payloads. All of those things are potentially disruptive. And clearly the trends are, as the technology matures, there's an appetite for that, because the reason we're going to hypersonics is so you can get to a target faster. Well, the next obvious step is, how do you actually employ speed of light kinds of techniques? And again, those are things that I think are disruptive to us. And figuring out from our perspective of what do we invest in current kinetic capabilities, vice how much money do we allocate towards R&D, towards these emerging things that will by nature be disruptive to our business. And again, you talk about culture and changing culture and disrupting, that's by nature. Disruptive technologies are hard to get traction in organizations. And so those are some of the things that I spend a lot of time thinking about and strategizing about, to make sure that, we're still growing 10 years from now.
Yep. Okay, excellent. I think that puts a perfect wrap on our conversation. There's a lot more we could talk about, some of which you've alluded to, some of which I have, but we have promised our audience that we would keep it to just this 1 hour, which has been great. Really, I think quite exemplary of what I aim for in the captains of industry this conversation has been. So let me just close with some thank yous, not least to you, Wes, for taking the time and being so very thoughtful about this topic. I actually think it has revealed a lot of things which some old timers, and I'll count myself among them, might not have associated with RM, the RM business that I've known for so many years. So new ground was plowed here. Let me also thank a number of others who made this possible, helped Wes and I rig it together at Raytheon, not least Sally Sullivan, but also on Wes's staff, Heather Ubruaga and Jonathan Murphy. I thank all three of them. In the Atlantic Council, I must thank the intrepid Christian Trotti and the indomitable Laura Macedo for making this happen. Of course, I also want to thank variously known as Ambassador Barrett or Secretary of the Air Force Barrett, as I know her better, and Byron. Thanks again, Byron, for helping us out on this. All of you who are watching should know, and please tell friends and colleagues, that a recording of this conversation will be available pretty much as soon as we're done here at the same link through which you registered for this event. And so I hope that there will be multiples, there will be leverage off of your word of mouth that we can enjoy and give others the opportunity to enjoy this conversation as much as I hope all of you have, and certainly the questions that Byron curated suggest that you did, and certainly that I did on behalf of the Atlantic Council. Thanks again, Wes. Have a great day. Look forward to seeing you again soon.
Thanks, Steve. Appreciate the opportunity to be here.